Shortest distance between two moving objects. Now this is the numerical given to you. Two ships A and B separated by a distance of 10 km. Now you are given ship A is moving towards B. This is velocity vector of A at the rate of 100 km per hour towards B. And B is moving due west at the rate of 100 km per hour. See, this B is moving due west. See, this is north, south, east, west. This diagram is given to you. This is VB vector and the value is given at the rate of 100 km per hour. Due west. Now what is given? See, you are given VA vector is in the y direction, 100 j cap, and VB vector is given due west, negative x direction, minus 100 I cap. And the question is to find shortest or minimum distance between these two ships. How will you find? Now this is from relative velocity concept. Put one ship at rest. Take one ship as the reference. Let us say I am taking A as reference. So we will write it like this. Relative velocity of B with respect to A. So this is VB vector minus A. First of all, find this. Relative velocity of B with respect to A. This is VB vector minus BA vector. What is VB vector? Minus 100 I cap. VA vector is 100 j cap, and this is the minus sign due to relative velocity. So take magnitude and direction. Magnitude of this relative velocity VBA vector is under the root minus 100 square, coefficient of I square plus coefficient of j square. It is 100 root 2 kilometer per hour. Now what is the direction? Now see, next part, direction. Direction of VBA, which is minus 100 I cap, minus 100 j cap. Now for direction, write the coordinates. Coordinates are minus 100, minus 100. Plot it like this, minus 100, minus 100. Now these are the coordinates of VBA vector. So with reference to origin, this is VBA vector. Now find this angle or this angle. Let us say this, tan alpha. It should be found in magnitudes after plotting. So this is base, perpendicular is minus 100. This is also minus 100, base it is 1. So alpha is 45 degrees. It means relative velocity of B with respect to A is 100 root 2 kilometer per hour due 45 degree here. Now plot it with reference to directions north, south, east, west, southwest. Since it is at 45, it is southwest. This is 45, this is also 45. Now see the meaning of this line. This is relative velocity of B. This is relative velocity of B with respect to A. See the two situations simultaneously. First, A is moving, simultaneously B is moving. Now see the second concept, second situation. Now this is relative velocity of B with respect to A. That means if A were at rest, this is called with reference to A. Only B is moving due southwest. Now see the southwest plane. This is southwest at an angle of 45. See, B is moving like this at an angle of 45. This is 45, this is also 45. It is moving at an angle of 45 like this in the southwest plane. See, this is southwest plane. Vector can be displaced anywhere in the space. or this vector is displaced over here. This is, B. B is moving like this. How B appears to A? B follows this track at an angle of 45 degrees and at the rate of 100 root 2 km per hour. So this is relative velocity of B with respect to A. Meaning A at rest, or what is the observation of A? With reference to A, B is moving like this. So what will be the shortest distance? This was given to us 10 km. Now draw perpendicular from here. This is shortest distance D, or the minimum distance D. Now in this triangle 90 and 45, it is base, it is perpendicular, it is hypotenuse. So this minimum distance upon 10 km will be sine 45, and this minimum distance between these two shapes becomes 10 sine 45. Sine 45 is 1 by root 2. So 10 by root 2 kilometer is the minimum or shortest distance between these two ships. Got it?